Welcome to this video. Today I'll be showing you how to count from, for example, binary to hex, from hex to decimal, and from decimal to binary, and so on. So let's start with binary. Let's start with hex. What is hex? So, normal counting system, we use 10 numbers, 0 to 9, and so, for example, you have if you have 1, 2, 3, this one is 10 to the power of 1, this one's 10 to the power of 0, this one's 10 to the power of 2. So say 10 to the power of 2 is 100. 1 to 10 2 is 100, and then 2 times 10 to the first is like 20, and then 10 to the 0 is 3, so 123. Well, with hex you don't have just 10 numbers, you have 16. So if 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you have A, B, C, D, E, F. So you have 0 to 9, which just work the same way as normal, and then A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So let's say we have 12. In the normal binary system you would just say it's 12, but here it's 16 to the power of 0 and 16 to the power of 1. So it's actually 16, because it's like 1 times 16 is 16 plus 2, which is 18. So 12 is not 12, but 12 is 12 in hex is 18 in binary. Alright, so say for example you have F, let's say 4. So F4 is 15 times 16 to the power of 1, which is 240. And then of course this one is 16 to the power of 0, which is just 4, so it's 244. F4 is 244. So let's say you have let's now say you have 3 like hex numbers. So 1 C A. This one is again 16 to the power of 0, so that's just 10, because if you can see here, A is 10. You see, so but this one 16 to the power of 1, so it's C 12. So 12 times 16 to the power of 1, which is, you can just leave the 1 away, so it's just 12 times 16. It's 192. This one, the new one, the 1 is 16 to the power of 2, which is, if I say it right, 256. So if you don't know, you can just enter in your calculator 16 to the power of 2 and you get this. So if, for example, now it's 1, so you just take 1 times 256 is 256. So that means that 256 plus 192 plus 10 equals 548. It's actually quite easy to understand. Now, let's say we have binary. So we have an 8-bit value of, say for example, 1, 1, 0, 1, 1, 0, 0, 1, 0, 1. So what you do is you take these two, you take two 4-bit values and divide them into, so you divide the 8 bits into 2 times 4 bits. And then in your head, what you do is you write down 1, 2, 4, 8. 1, 2, 4, 8. So let's start from this one. This one's a 1, so 1. This one's 0, so nothing. This one's a 4. This one, the 4 is a 1, so it's it's true. So there is a 4. So now we have 4 plus 1 in the first 4 digits. Then this is just 5. Then we take 6. Yeah, we have 2 plus 4, which is 6. So 1, 0, 1, then you just add these two numbers together. So now you get 0, 1, 1, 0, 0, 1, 0, 1 is 65 hex. So, for example, if it wasn't this, but this, so you have 0, 1, 0, 1, it would be 8 plus 2, so 8 plus 2, which would be A, so which would be 10, so A. So then it would be A5, which we again can convert to binary. So A5 is 10 times 16 plus 5, which is 165. So the value 101.001 is equal to A5 hex, which is equal to 165 binary. So now you might be asking, how do you directly go from how do you go directly from binary to decimal? That's also quite easy, but a little more involved. Alright, now let's say we now go from binary, which is called base 2. Our decimal system is called base 10, and like the hexadecimal system is called base 16. That's because you have two values in base 2, so binary, you have 0 and 1, which is 2 possible variants. Here, it's quicker to do this. In our base 10 system that we use every day, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. But in hexadecimal, of course, it's 0, 1, 2, 3, 4, 5, 6, A, B, C, D, E, and F, which is 16 possible characters to use while counting. So this one is called base 2. This one, base 10. Hexadecimal is called base 16. So if we now want to go from, let's say, binary, so base 2, to base 10, that's also quite easy actually. All you have to do is, say for example, you have the value 0, 1, 1, 1, 0, 0, 1, 1. What you do is, instead of dividing them into two different things, you just keep them one. So what you do, you write 1 here in your head. You don't really have to write it down every time. You double 1, you get 2. You double 2, you get 4. You double 4, you get 8. Then you double 8 and get 16. Then you double 16 and get 32. Then you double 32 and get 64. When you double 64, you get 128. And now all you have to do is just 1 is true, so we get a 1. Plus 2 is also true, so we get a 2. Plus, you can see 16 is true. Plus 32 and 64. So if you just add these numbers together, we should get a value out of this binary number represents the value, so this 8-bit binary number represents the value 115. Okay, these two are actually like the same number. Now, how do you convert from decimal to binary? So remember, an 8-bit value in the binary system, so base 10, in the decimal system, base 10, can be 0 to 255. So 256 different possibilities of numbers. So let's say we take a number within 0 and 255. So let's say 147. What we first do, so you remember we had the possible things we could do. We could subtract, like, was add together was 128, 64, 32, 16, 8, 2, and 4, 2, and 1. So let's just start with the first one, 128. What you just do is you take the, you see 128 is lower than 147, so you can subtract 128 from 47, which gives you a value of 19. So this bit is true. 64 is higher than 19, so you can subtract it. 32 is higher than 19. 16 is lower than 19, so you can subtract it. So now we subtract 16, which gives us, I believe, 3. Yeah, 3. So we have this one. 8 is higher than 3, and 4 is also higher than 3. 2 and 1. So let's subtract 2 now. 2 and 1 are lower. So now we get 1, and 1 minus 1 is 0. So now we have the value 1001011. Now if we check it with our calculator, putting the output mode to the mode to decimal, and enter 147, which we want to display in binary, 10010011. This value here is the same as this value. So that's how you go from a decimal number to a binary number. So from base 10 to base 2. Alright, so for hexadecimal, let's say we have a value of 9. Normally you would think, because it's hex, it's A is 10, 10 times 16 to the power of 1, aka 10 times 16, plus 9, because 9 is just 16 to the power of 0, which is just the same as multiplying by 1. So that's 160 plus 9, 169. Nice. That's what you would think, okay? But that's incorrect. You could use it this way, but what you also could do is split these two into 2, and once again apply the doubling logic of 8, 4 to 1, and that times 2. So here 1248 and here 1248. So A is 10. As we can already see, 8. We just work our way backwards. So 8 is lower than 10. So we can subtract 8 from 10, which gives us a value of 2, which you can already see is lower than 4, but equal to 2. So we can just subtract 2 to get 0, and then we have our first of the first 4 of 8 bits. So the first 4 of A9 is 1010. The second one is 9. Once again, we can subtract 8. So 8, 4, 2, 1. 8 is lower than 9, so we can just subtract 8, which gives us 1. Well, 4 and 2 are higher than 1, so you can subtract those. And 1 is equal to 1, so you can just subtract those, get 0. And these two are your binary value of A9. So A9 is equal to 10101001. So if we can check, so if we're gonna quickly check this again, shift menu for the Casio calculator. Mode, we want hex. So A9, so we just click A and 9. And then display in binary. 1011001, which once again is the same as this. Alright, let's recap. If we want to go from hexadecimal to decimal, what we do is we take the first value. So for example, we have one FA. So as we know, 16 to the power of 0, which is just times 1, 16 to the power of 1, which is times 16, and 16 to the power of 2, which is 256. So we have 256 plus F, which is 15, F is 15, plus 15 times 16, which is 240, plus A10, which gives us a value of 506. So 1FA is equal to 506. What's your use for this? Well, say for example, you have on a website, you might see a color code like 2B69 to let's say 3A. You might say, well, how do I know what color this is? That's quite easy. A screen has 3 different pigments. So we have red, green, and blue. So what we could do is we take these 3 hex, we take this hex value and divide it into 3. So we have 2B693A. 2B converts to 2 times 16, 32 plus 11. 32 plus 11, which is 43. Um, 69, nice. is equal to 6 times 16 is, let me just quickly check here, 96. So 96 plus 9 is 9. 9 is 9 because, well, again, 16 to the power of 0 is just times 1. So we get 105 for the green color. Blue is 3 times 16 is 48 plus 10, which gives us 58. So we can check this. You see, I already have a color here because reasons. 2B693A. We can see 43,105,58 is the hex color, which it corresponds to this color. So the hex code 2B693A is equal to dark, little bit darker green. Alright, let's now go from hex to binary. Say we have the let's do 12 bits because 12 is 4 more than 8. So what we could just do is so if we just have A, B, which is a binary, if we then just add 1 in front of the A, like 7, what we then can do is divide these into 3. 7 is, once again, if we think 7 is less than 8, more than 4, more than 4, so we can just subtract 4 from 7, which gives us a value of 3, and then we can subtract 2 and 1, because, well, yeah, we get 0, so it's the first 4 bits are 0, 1, 1, 1. A, once again, is 10. 8 is less than 10, so we can subtract 8, which gives us 2, and then we just subtract the 2, which gives us 0, which then again, we use the 8 and the 2, so not the 4 and the 1, so that's 0, 1, 0, 1, 0. B, 11, 8, subtract from 11 because 8 is less than 11, 3, and then we just subtract 2 and 1 again, which gives us 0, so 1, 0, 1, 1. So the total of 7AB is 0, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 1. Which, let us just quickly check. Mode again, hex. We have 7AB. If we then display it in binary, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 1, which is the same as this one. So 7AB is equal to 0, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 1. Now, let's convert binary to hex. We're gonna take a 10-bit value, so 10 zeros and 1. We have 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. So let's say we have this value. How do we convert 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 to hex. First we divide the 4s, the 8, we divide them into sections of 4. Here there are only 2, so we just divide them into a section of 2. You can always have, if you divide them into 4, you can always just have less than 4, never have more, because that wouldn't make sense. So again, as a reminder, 1, 2, 4, 8. 1, 2, 4, 8. The same with this one, and with this one we only have the first 2 digits, so it's only 2 and 1. Alright, let's start here. We have 2 and 1, which gives us 3. Here we only have a 2. You see, the other ones are 0. So 3, 2, and then we have 8, 4, 2. 8 plus 4 equals 12, plus 4 is 14, and 14 is E. So 32E is equal to 1100101110. Okay, let's check that. We are going to binary 32E to hex. No, to binary, which, wait, what? Oh, of course. We take 1100101110, and we convert that to hex, which gives us 32E, which is this one. So as you can see, that's just quite easy. Let's take a decimal, so base 10, our counting system, and convert that to binary, base 2. Let's take a 14-bit number. Let me just, which gives us 16,384 possible outcomes. So 16384. We can just check that by taking 2 to the power of how many bits you want. So that's the amount of possibilities. So now let's take the number 12,634. What we do now is we have 14 bits, so it's going to be a little bit hard, but we're going to double until we have 14. So we have 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. These are the possible numbers we can use to convert this. Alright, 8,192 is less, so 8192 minus 8192, which gives 4442. So for this one, this one we give a 1. 4096 is less, so we can subtract that again. $346. This one's a 1. This one, 248, more than 346. This one also more. This one also more. This one's less, so we're gonna use this one. Which gives us 90. 92, 128 is possible, so 64, it's less, so we can subtract that one, which, let me just quickly scroll down, which gives us 26. So 64, 132 is more, so that one can't. 16 is less, so 16, which should give us 10, yes, 10, okay, 10. We used 16, right? Yeah, okay. 8. We have 10, so we can subtract 8, which gives us 2. So 8. 4 can't, and 2 we can use, so 1. So what we end up with is the number 12,634 is equal to 1 1 no wait sorry 1 1 0 0 0 1 0 1 0 1 1 0 1 0. These two numbers should be the same. So let me 0 1 1 0 1 0 2 decimal, yeah, it's 12,634. Easy peasy. And last but not least, we go from binary to decimal, which I'm just quickly gonna do because it's quite self-explanatory by this point. So binary to decimal. We're just gonna take, I don't know, a 9-bit value. I know it's not really common, but why not? 1 0 1 1 1 1 0. Okay. Well, let's start at the end. 256 is a 1, so we just add that one to the counter. The next one that's true is 64, 128 not, isn't. Plus 32 plus 16 is, it's not very clear, but that one is 64, is that one is 32, that one's 16, that one's 8. So 16 is also 8 also, and then 4 and 1 not, so only 2 is left. And if we then just quickly calculate that, 6 plus 64 plus 32 plus 16 plus 8 plus 2 gives us 378. Now if we quickly binary 1 0 1 1 1 1 0 1 0 2 decimal 378. Alright guys, there you have it. This video will hopefully have taught you how to go from binary to decimal, go from decimal to binary, from hex to binary, from binary to hex, and from hex to decimal. Alright, so thank you very much for watching, and I'll hopefully see you later.